Good morning, good afternoon, good evening from wherever you're watching around the world. Welcome to today's webinar on GemFire Vector Database. I'm AJ, but I'm not today's presenter. I'll be introducing today's presenter shortly. Before we do, just a few housekeeping items. First, we'd love to keep this as interactive as possible. So if you have any questions throughout today's presentation, submit them using the Ask the Questions tab below, and we'll do our best to answer all of your questions live throughout today's presentation. In addition, we know that you guys are here to hear from us, but we love to hear from you. So there's also a rate this tab below the presentation screen. Leave us feedback, let us know how we did, how we're doing, or what you'd like to hear at future events. With that being said, I'd like to bring in today's speaker. Today's speaker is Director of Product for GemFire, Charlie Black. Hey, Charlie, how you doing?
Great. Thanks for introducing me there, AJ. All right, so let's get into this. So today we're talking about GemFire vector databases, right? So we came out with a new extension to GemFire. It allows you to do vector database work, and I'm going to talk about that today. So I like to always talk a little bit about what is GemFire, so that way people can at least understand why, get a better lens and why the vector database on top of GemFire makes sense, right? Um, and then since you're going to be having GemFire in your architecture, you might as well hear about a couple features. Then we're going to talk all about vector databases, and that landscape is a, awash with terminology. So we're going to make sure that everybody's leveled up on some of the terms in the vector space or even the vector database space. All right. We're going to show you a little bit of code and see a demo. So hopefully I get everything squeezed in the time allotted here. All right. So let's start off with what is GemFire, right? The elevator pitch. GemFire is an enterprise-grade, high-speed, in-memory data compute grid for a high-performance, low-latency application where data must be consistent, sub-millisecond response, scalable across multiple data centers. Simple terms, it's fast, makes it awesome for vector databases, right? So really good stuff. Just think about GemFire's just in-memory performance really fast. How does it get there, right? So how does it get to be fast? And what makes it so special is it's shared nothing architecture. And what that's saying is, as for each member in the GemFire distributed system, right? Because it's a distributed database, each member has its own CPU, RAM, disk. So when we're doing transactions, there's no sharing of CPU or disk drives to do any weird locking. So that ends up getting us to be significantly faster, right? So if I need to also scale, I can actually just dynamically add and remove servers at any time, right? With no interruption of loss. So let's just say I'm using, I'm hitting a certain scale point. I need to grow it a little bit more. GemFire can do that for you automatically without any application, right? You almost don't even know that it went on, except for now your responses are getting faster. Really good stuff. Some common GemFire data storage patterns, right? There are customers out there using GemFire in a myriad of different ways, right? There's customers that are using it for a system of record. So that's just basically like GemFire is the only database that they have. There's a lot of times when you're just getting started, the cache aside pattern, or you like using Spring, right? Spring at cacheable annotations, cache aside pattern works really well, right? Read and write through. I like this one a little bit more, puts GemFire in control of it, the database in control of it. So like if I'm looking up a given data value, say I'm loading a web screen with Charlie on it, I don't have to hit that backend database a bunch of times. GemFire will make sure it only gets hit once. So it helps you out with reducing costs on the back end. That can turn into dollars, right? If you think MIPS from a mainframe perspective, or just dollars, right? From like, say, I'm calling OpenAI and I want to cache results from OpenAI, some other generative AI system. Really can do some really good stuff there. And then right behind, so you have your huge transactional volume going on in GemFire. Let's just talk about performance there. A typical GemFire performance, it's not uncommon to see like millions of transactions per second. I think we've tested up to like somewhere around 4 million operations per second. So really good stuff, but that might crush your backend system. So what we could do is like coalesce the events, get things going down so that way we, do bulk operations to the lower end, inferior backend systems, right? And then just daily, just load the cache, right? Just use it as plain old cache. That one's kind of boring, so I don't really like to talk about it. Anyway, you get the idea, lots of applicability, and now we're going to be adding, vector database stuff to it. So where can GemFire run and GemFire vector database run? Well, it can run wherever you want. Public cloud, private cloud. You want to do hybrid? We have this technology that I'm going to talk about later on where you can basically cloud burst with GemFire, right? Have your on-prem and your cloud infrastructure, and they're just syncing things up. GemFire can do that for you. If you're doing Kubernetes, vSphere, we're there for you. Bare metal, we got a bunch of customers on bare metal as well because they want to get the ultimate performance, right? Not have anything in the way. So I'm going to use the word region quite a bit. That's basically the way that we store things. And at the end of the day, what is a region? It's just a concurrent hash map. So you just put and get in the vector DB space. We'll see the API in a moment. So for your job, your teams that are adopting GemFire for outside vector database work, it's really simple to adopt. It also has, on top of a semantic querying, you can also do just standard OQL querying. So now I can go off and navigate my objects and my regions and basically navigate object hierarchies with OQL. It's really powerful. So now if you think about it, I have all these domain objects and they have a position. So I can actually navigate through the positions, get the values from there, and then look for all the objects in the region that match VMware. Probably should change that to Broadcom, but do that next. And we support event-driven architecture. So GemFire was built in the modern age, so everybody wants to get alerts on everything. So when you do a storage operation, it gets broadcasted in many ways. I can do things on a server, on a client, where I'm just getting all events. I could actually put a filter predicate on there using OQL, where I could say, hey, I'm only interested when some threshold gets above something else. Another one is competing consumer pattern, and this can be done in the grid, right? So now I can spread that load out in the server topology. Really good stuff. And one thing I do like about having in the server is now when I go to do some really low latency operations, I can actually route the event to where the host data is hosted. So I don't even have to make a network hop to do any work. It's really powerful stuff. All right, and then keeping your data safe, right? So I left these slides in here just to talk about data safety, and this applies to our vector database work. So GemFire has this concept of just, disaster recovery, high availability. So if we're talking about, hey, I want to make sure I'm the utmost of safe, you can have it. We have a concept of availability zones. This can be racks, it can be data centers, it can be whatever it is that you think is good for that has a good low latency network. And we'll synchronously keep everything in available for you. Yeah, so let's just go on with the slide there before I get too technical and deep into it. So in this setup, basically what we're doing is we want to make sure that we have some really good availability. So I'm spreading my GemFire grid across 3 data centers. So that way, when I do have a failure in a data center, like, little happy fire, a little rain that just floods somewhere. GemFire is keeping your data safe because it was keeping copies of data on the other nodes, right? So if I lost that whole data center, it's okay. So GemFire is really safe on, really good for keeping your data safe. So that's super awesome stuff, and it's a consistent database. So you know that like when your application writes, it's everywhere on the grid. Okay, let's talk about GemFire WAN. So this is probably really cool from hey, I'm loading my vector database work. I'm loading it into GemFire. Hey, where I can actually have that go across the globe, right? I could have data centers on the East Coast, West Coast of USA, UK, Tokyo, India, wherever you're at. We can basically span the globe and keep those databases, those vector databases, and whatever your application is doing all in sync. We have two methods of operations on this. So, because data's kind of got these interesting ways of thinking about things. So thread ordering, so we can keep strict thread ordering on the WAN. This is probably the slowest, the serial. Basically, all writes from the grid have to go out through one computer, so that way we get that strict thread ordering. Parallel, you can keep that thread concept, thread ordering concept, but it's on a per member, right? So, host A is just getting a bunch of traffic, and all the data from host A goes out of host A. Thread ordering, member keys, right? So all the data that Charlie is interested all goes out in the same order. A lot of times that's what I recommend starting out with, is just saying, hey, get it on keys, and then you can get a nice, good throughput on there and keep everything for a given customer or, device or whatever it is in strict ordering. So really good stuff. Okay, so this is the last slide on GemFire, I promise. So what can you do for this? Let's just wrap this up. So, traditional databases just can't scale as well as GemFire. I mean, it's super easy. Just throw another node on there. If you're having scale problems, just throw another one on. We'll just dynamically set everything up. And your applications don't even have to know. Low latency data access, right? Just GemFire is crushing it with single digit or less performance, where your traditional ones might be a little bit slower, double digits, if not even longer, right? A common use case for GemFire is session state management. It's super easy. We have an adapter that hooks into most app servers, and we can just do transparent session state management for you, right? I had a customer that was whenever they did an update, it logged out all their customers because they weren't storing their session state in something like GemFire. They were storing it in the app server, and then when they rolled the app server, it lost a bunch of data, right? And forced all their customers to relog in. It was kind of not that cool. Scalable data storage and retrieval, right? This is just me talking about scalability, right? Just throwing another server on. Data synchronization and replication, we're just keeping that data safe using the availability zones, the redundancies that we have in there, and keeping data safe across the globe, right? And that's the important one. And then we learned a little bit about event-driven architecture and real-time analytics, right? So all that event-driven architecture that I was talking about, where we could have it from a client perspective based on a predicate, query predicate, or just competing consumer, where you have all the events being spread across the grid. We could be running some really cool ML algorithms in there. And I've done that many of times, where we're basically scoring data, enriching it, so that way we can make better decisions later on. All right, so let's jump into what is a vector database and get into the heart of this, of GemFire as a vector database. All right, so key term, what is a vector, right? So a vector is just a array of something, right? So array of of numbers, right? Just a bunch of floats. So that's all it is, right? Now in the AI or LLM space, I'm going to talk about what that is in a second. But in the AI space, we call it embeddings, because what we're going to do is we're going to look at something and we're going to group them based on has some kind of meaning to them, right? So a dog, or a picture of a dog or a cat is all in the same spot, so that way I can go query them, right? And another idea way of looking at something is like XYZ coordinates for a vector, right? So hey, my Charlie's in this XYZ space. Things that are related to Charlie are in that same kind of thing, but what about a person, right? It's more conceptual. That gives you an idea of what embedding is. Now, one of the key things is, while all embeddings are vectors, not all vectors are embeddings, right? So embeddings have additional meaning on it. Vectors are just themselves, right? So that gives us an idea there. All right, so for our 2D learners, right, this one's the one that got me to understand some of this stuff, right? So I threw up a couple pictures, right? A Lego space guy, a spaceman in the desert, and a desert picture, right? So if I was to map in some additional imagery or additional text into this, so that way we get an idea for how this is kind of working. So if I ran a query of Lego spaceman, right, or was looking for other things like a Lego spaceman, I would type in Lego spaceman and it would get there. So you get the idea of, like, when I'm shooting these vectors into as a query, I'm actually just going to that space where it's closest to what's going on. A better idea is spaceman. Doesn't really hit these two images, but they're somewhat related. So I would do a vector search, and what a vector search ends up doing is finding the nearest neighbors, right? So the nearest neighbors to spaceman in this image is that Lego spaceman and the spaceman in the desert. Then, like, similarly, right, I have the spaceman in the desert. It's close to that spaceman in the desert, kind of close to the desert. So I might see those two images in that query. And I'll show you that in the demo in a moment. Likewise, we have the desert there, and it's pretty close to it. All right. So the role of a vector database is to efficiently store all those vectors, right? So how big can a vector be? I forget what it is in this model. I think it's somewhere around 768 dimensions, right? And I believe OpenAI is at 1500, somewhere really close to there. And so you get the idea. It's an array of a lot of numbers. So a vector database is designed to store and manage and just do its best at keeping that inexpensive to store and fast to retrieve. So in our implementation over the vector database, we use a thing called HNSW. What that is it allows us to do an approximation search, so that way the queries are faster. If you don't do that, then you're kind of grinding through every single node to get in there. So there's a little bit of approximation to get to some of the speed that we get out of GemFire vector database, but it's good enough to give you a good search. All right. And then we'll add in other algorithms as we go along, because this is the version 1. All right, LLM stands for large language models. This is super common, right? So how do I get that embedding? Well, to get that embedding, I have to run it through some kind of large language model. This is where everybody starts thinking about AI, right? So the large language model starts mapping things, and it'll map something to the dimensional space that I can then query. So it's really important to have an LLM, so that way you can run your data through it. So what are some of the things that I can run through an LLM? Well, text is easy. Everybody's seen ChatGPT, right? So I can go through and I can run it through a model and generate some kind of result. I can definitely run images, audio, basically almost anything, right? If you haven't watched the Google Bard thing, that gives you a good idea for the space that you can run through some kind of AI model. So what a typical pipeline would look like is I take my images, I encode them with an LLM, some model, right? And typically that's what needs GPUs. So if you're like thinking about, oh, I need all these GPUs for vector database, kind of helps, but you don't need it. Um, anyway, so you get the LLM that generates an embedding. You take that embedding and then you insert that array of floats into GemFire, right? So that's super awesome. GemFire itself can, we were doing some studies around Postgres, and it was about 4.5 faster, right? 4.5 times faster than Postgres on just doing that insertion rate, right? So we could just jam a whole bunch more stuff in there. So that's one of the reasons why you would use GemFire Vector DB over, say, a PG Vector or something like that. Okay, and then how do I query that data? Well, I have to take that same query, get it into that dimensional space, right? Get it in there, run it through the model, and then that generates an embedding, and then I can use the vector database to do that near search, right? What else is in the dimensional space? Where is that picture of the spaceman relative to my query of space, or the spaceman in the desert to spaceman? That's a responsibility of GemFire to tell you that what are the closest objects that it has stored in its database. So let's jump into a demo, and I'll kind of walk through some of what's some of the code around this before I even get into just showing you what's going on. So let's dive in. So I preloaded GemFire vector database with a bunch of sample data. It's roughly about 25,000 images. Takes forever to encode it, so there's a cached version of the results that we ran through the LLM just to make it super easy. So anyway, we did it one time, and it was taking a long time because we weren't using GPUs. Anyway, so I took this 25,000 images, ran them through an LLM, generated the embeddings, stored them off so that way they can be reused. If you go look at the source code, it'll download it from somewhere. And GemFire vector database, we just store all those embeddings in there. So I talked a lot about it. It looks like an array. I figured I'd just run a query. In GemFire, our command line tool, it's called gfish. And I went off and said, hey, go give me the key and the value, because GemFire is, at the end of the day, a key value store. And I want to see, what does the key look like? And for this one, for the sample application, we took the key. We didn't store it. We have another concept of metadata around the vector, because the vector itself doesn't have human meaning. It has more of the meaning for the model. So, you want to keep some kind of metadata, and keys are perfectly good idea for it. What that allows us to do is look up our image. So when we're doing this demo application, which is an image search, I can then just display the results that came back. You can throw a bunch of data in there, whatever you want to put in there. Names, like if you're doing PDF documents, you want to take some paragraphs that that was part of the result set that you want to put in there, you can easily do that in the metadata, and then URL links to wherever it is. All right, so anyway, I ran a query. I'm getting the key and the value. I only wanted to look at the vector. I didn't want to see the metadata and the region that it was in. And I can look at the entry set. So like at the end of the day, it's a hash map. You can go get the entry set on get entry set, I think, is the method. And then we can look at the keys and the values. Really cool stuff. Shows off a little bit of the power of OQL as well. All right, so like I said before, the generic pipeline applies still here for how do I query a vector database. We showed how I kind of loaded it. Now we're going to query it. Basically, I take from my search bar. I then encode it. There we're using Python. The app server I think we're using is Flask. It generates the model. The model gets instantiated. We generate the embedding. we then query the database to go find the closest vectors, and then we present the results. Feels easy. A lot of complicated stuff going on, but it feels pretty easy. Once you get over all the concepts, it actually is pretty easy to be in this space. So let's take a look at that. The model, let's dive a little deeper, right? The model that I'm using is a model that's free to use. It's up on Hugging Face called ClipVit B32, right? And what CLIP stands for is contrastive language, whatever, you can read the text there. But the interesting thing about this was it allowed text to image, image to text, image to image, text to text, right? It was pretty wide using, right? So not only can I have it look at a bunch of images, I can then search for those images. So I figured, hey, why not just make a cool demo out of it, since it was out there for free to use. And I like their like example of the vectors, right? Where they have a cat on a table, two dogs in the snow, matches up really close to two dogs in the snow. So when I go look for two dogs in the snow, I'm probably going to get that picture, right? We'll probably do that as a search, play around a little bit with the vector DB. Can't think of what else to say about it, so let's move on. I'm pretty sure I had another thing to help you out with what that's there. So this is our loading, right? Picture this, of course, in a for loop or something like that, where you would then iterate over everything. This is the code, right? So I go off and instantiate the model, and we're using, I think PyTorch at the end of the day. We go ahead and code the model by opening in the images, right? Run it through there. We get a vector back. We create a document to store in there. And I'm going to do a bulk load of everything. So that I do a for loop over a bunch of them and then post them to GemFire, do a bunch of inserts. That's pretty basic, right? At the end of the day, I don't have much. It's not hard code, but it's super awesome on the concept. And then for querying it, it's the same thing. I instantiate that model. I go ahead and query it. I get my vector to query there, and I have my query document. It's basically the array of floats there. And then I just say, go query and give me my response, which will come back as with the nearest neighbors, right? And what's hidden in there is that you can say, how many do you want? All right. And, you can come back with 100, 10. I think for this demo, I limited it to 25 or something like that. But you get the idea. You can go off and query it pretty easy. All right, so let's see this in action here. So I think it was share screen.
I do see, yes. There you go.
What was that? All right. Bright Talk, share screen. And so here's one where I did House on the Hill. Let's go ahead and do a search for everybody. So that way we can get what's going on here. Let's see. We had two dogs in the snow. Two dogs in the snow. So it's total demo. So you can go off and delete the index, load it up, and do it all through the UI here. But anyway, two dogs in the snow. Let's go off and do search images, right? So went off, encoded that text, sent it off to GemFire. GemFire comes back with the results set, and we displayed a bunch of images, right? Two dogs in the snow just happens to be the top query that was showed in the video. So let's do another one that's kind of fun. Let's do the Spaceman. Spaceman, so that way we can see that in action. We hit search, and we get the little Spaceman. I don't think that other one was there. These are probably more relevant. But let's just say if I did Spaceman in the desert. These are all pre-canned. Let me see if I can think of one. So let's try to get this image, right? And open mouth camel. So again, search images. Hopefully you get the idea. Oh, well, I didn't find that one, but you get the idea. It's pretty powerful little demo here. Code's all open source. I'll show you a link in a moment for it. So let's see, what else can I talk about with this? Nothing. So let's go ahead and stop what's going on. Let's see, slides. I think I stopped sharing, and then slides. Hopefully you're all looking at the slides. And let's
We see the slides.
Thanks, AJ. All right, so we learned a lot, right? I jammed this in. I guess I was supposed to talk about a couple of other things, and I messed up, but that's all right. We learned a lot, right? We learned GemFire was fast. We even saw some of that, right? I don't know if you would have ran this on some other database, on some VM that you have running locally. Scalable, keeps your data safe around the globe. We built up our vocabularies. Hopefully you learned something about the vector database space and all the terminology that can go around there. That clip bit 32, whatever it is, that one's pretty cool, right? It's a really cool model. Go use it in your applications. Give GemFire a try. The demo, and you'll see the source code in a moment. And I hope I demystified something around LLMs in the vector database space. If you want to learn more, you can head over to GemFire Dev. There you can download GemFire, the vector database. You'll see the documentation on the pull down there. You can get the documentation, examples, blogs, videos, source code. And then if you got a screen grab, you can get the URL, direct URL there. If not, just go to GemFire Dev. And I believe it's one of the first blogs on vector database that has talks about it in text format. All right. That is about all I can think of for today. Sorry for about making it short, but it's short and sweet. If you have any questions, there's AJ. So I was going to wrap it up for you, AJ. If you want to do it, go ahead.
Yeah, great questions. We have a lot of great questions coming in here, Charlie. We can get to them. Charlie, sorry, go ahead.
Okay. Oh yeah, the questions. Totally forgot about those. Let's see, audience questions. Can you expand on latency?
There you go.
All right. What would be the max latency allowed in between AZs? So that goes back to the slide where we're talking about availability zones and redundancy. I mean, availability zones and I think it was availability zones. All right. What's the max latency that you should allow in between zones? The lower the better, right? Is there some point in time that you would want to have a number? I think about it as the more latency that you get between availability zones or between data centers causes more and more problems, right? So meaning, let's just say I have a single threaded application. If I have a large latency between the data zones, that means that that thread of execution can be only that fast. Now, luckily, we have many app servers and many users using the system, but as the latency between the data centers gets larger, you might not want anything. So I like to say, rule of thumb, 10 milliseconds or less is where you want to try to shoot for between availability zones. If you start going over that, you might impact your application SLAs, and that's what I care about more, right? Don't forget, we also have this WAN capability. So if you start getting into above that 10 milliseconds, start thinking about WAN, right? And we'll keep those data centers in sync. It's just asynchronous. So that way the slowness of that network doesn't impact your local performance. All right, another question was, can I use GemFire vector database to cache results from generative AI that have costs associated? Yeah, sure. Let's talk about OpenAI, right? So I could take, say, that VIT32 model, right? And I could take the query the prompt that I've sent out there, and then take that result and store that in GemFire, right? And the GemFire vector database. So I can take the semantic meaning of the query, and then that's the vector that I would embed. And then if somebody comes in there for a second query, right? So I want to say, what's the weather in San Diego right? And I can cache the result. And likewise, I come in and say, what is the weather in San Diego, California, right? So that's where I live. So it might come back and give me the same answer there. So really good stuff to give you somewhat close of an idea for what you can do with, say, generative AIs, right? And at enterprise scale, that might save a ton of money, right? If you have a lot of users of that generative AI. Plus, there's also the compute cost, right? So if you're hosting your own, there's the compute cost. And at the end of the day, compute always costs something. Why would you use this over, say, some other competitor? We briefly touched on it, right? So I'm going to just say those words again. So we're about in some tests, we're about 4.5 times faster than Postgres, right? So just, I believe that one was loading data, right? So just loading data, just getting the data jammed in there, we're 4 times faster. We're faster on just about every front against Postgres. Another competitor that I've encountered quite a bit is Redis. Now, on that one, we're about 5 times faster. And that's mostly around when we start talking about at scale, right? So GemFire itself is a multi-threaded system that can handle concurrent workloads, and you can just scale that thing up. Redis has mostly single-threaded, right? So it doesn't handle scale that well. So 5 times slower when you're actually doing real work, right? It's not like I had a lot. I think I only ran it up to about 100 concurrent users, and it was just falling on its knees. So really good stuff. GemFire is just kind of keeps your data safe, keeps your vector database safe, and then you can spread it across the world. So that way you can have that geographic closeness to get that speed up there. Really good stuff on top, building a vector database on top of GemFire here. Hopefully those answer the questions. It's all I can see there. That there might be a couple of repeats, but those are the ones I could see. I don't have anything else. Anything else, AJ?
No, I think Charlie, just want to say thank you again. The links that you guys see on screen here are available in the attachments side of the attachments tab below. So if you just click on the attachments tab below, you should be able to click on the both of these links that are available. In addition, we do want to just say that this event has been recorded and will be available post-event. Charlie, I know we've done quite a few webinars together, so we're looking forward to having you back on to host another webinar with us. If you have any questions for Charlie, you can feel free to message us here during this event or post-event, and I can get the questions over to Charlie. We can respond via email.
Yeah, and if there's something that you want to hear special, I'd like to hear that comment.
Let's do it. All right. Well, perfect. I just want to say thank you again, Charlie. Thanks to everyone here in attendance, whether you're watching it live or in the future. Hello from Charlie and AJ. Everyone have a great day. We hope to see you guys soon.
All right. Cheers.
Bye all.